All right, this is 13.1, day 2. Today we're going to start talking about some terminology that we should already know. So if we are asked to find where a graph is increasing, that means we want to know where there is a positive slope. Over what interval is there a positive slope? Well, a positive slope means the graph is going upward like this. We have two notations that we use for this. One of them is just algebraic notation. So when we look at where is it increasing, we are saying what are the x values for which this graph is increasing? Where is it going up? So it's starting here at that x value of -1, and it's going on and on forever toward the positive x's. So it's going toward positive infinity. So that means the x values here, we would say in interval notation, -1 to infinity. And in algebraic notation, we would say x is greater than -1 because we're looking at all the values that are bigger than -1, from -1 to infinity. Well, what if we want to know where it is decreasing? That means, where is there a negative slope? So for a negative slope, that means where is the graph going down when we look from left to right? And from left to right here, it's going down from here, and notice there's an arrow. So it really is going like this forever and ever, and then it stops here again at -1. So this time it's starting technically at negative infinity because that's where the x values are heading. They're heading this way to negative infinity and going all the way to -1. So in interval notation, that would be negative infinity to -1. And in algebraic, that would be x is less than -1 because we're looking at -1 and all the x values going this way. Well, now if we talk about positive and negative, let's start with positive. If we want to know where a graph is positive, that actually means where are the y values positive. And that tells us to look above the axis. And I'll show you what that means. If we are looking for the positive y values, our y values, this is our y-axis. Where they're positive is here, 1, 2, 3, 4, 5, etc. So that means where a graph is positive is where is it above this x-axis. Well, this time we actually have two intervals. This one over here goes to -1, 2, 3, and this one is at 1. So for our interval notation, we would say that this goes from negative infinity to -3 or 1 to infinity. So it is positive in this interval over here, that's this one, and it's positive in this interval from 1 to infinity. Now in algebraic notation, we would say for this one, x is less than -3 because these are the x values that are smaller than -3, -4, -5, etc. Or x is greater than 1. And then similarly, if we want to know where our graph is negative, that means we want to know where the y values are negative. And that tells us to look below the x-axis. So that is going to be this section. And we see on this section we only have one interval. It is negative from this point to this point. So it's negative from -3 to -1. So in interval notation we would say -3 to -1. And then in algebraic, we would say -3 is less than x is less than -1. Now, some of you may be wanting to put brackets here or equal tos, and that's totally fine because that is one thing we did when we learned this. The way we're going to determine whether to use parentheses or brackets is based on what we're asked below in our questions, and I'll show you that. So that's a review on the terminology. Now let's go practice it with slightly different wording. It says that we want all the values of x if f of x is less than or equal to 0. So before we determine that, we are actually going to draw a number line of it. Well, to do that, we have to know what the question asks. It says all values of x if f of x is less than or equal to 0. This tells us we want to know where is the graph negative. How do we know that? f of x means y, so this tells us where are the y values less than or equal to 0, which means where are they negative or where are they below the axis. So let's look at our graph. Where is it negative? Where is it below the axis? That's going to be this section, this section. So on this one we have two intervals here. Before we write out the intervals, let's look at a number line, because we can actually draw this on a number line. Well, to do that, we just need our 2 points on our number line. Those are the points that they are coming to an end, or that's where it is, I guess, starting to be negative, and that's going to be -2 and -1, 2, 3, 4, 5, 6, 7, 8. -2 and -8. Then it is negative going down this way, but it's also slowly moving to the right, and this one is slowly moving to the left. So on this, we are going to put closed circles because of this or equal to, and then we're going to put our arrow to the left and to the right. So this is like graphing inequalities, where we have, it could be this section that's less than -8, it could be this section that is greater than -2. So we are putting this on a number line and just showing these are the values where these are the values of x if y is less than or equal to 0. And then we can write this in our intervals. So this would be x is less than -8 or x is greater than -2. Now what am I missing on those? The or equal to, because we are using less than or equal to, that means we want the closed circles. And then in interval notation, that would be -∞ to -8 union -2 to infinity. And then of course we would actually want these to be brackets because of the or equal to. All right, next one. All values of x if f of x is greater than 0. Strictly greater than, not or equal to. Greater than 0 means where is it positive? Or where is it above the axis? So this means positive and above the axis. Well, where is it positive? Let's start with our number line. We just look at the zeros because that's where it crosses. Our zeros, again, are -2 and -8. So we look at those zeros. This time it's positive between the zeros from here all the way to here. From -8 to -2, it's positive all in between them. We're going to use open circles because this does not have the or equal to, and we're going to graph in the middle because that's where we see it's positive here. Some of you may have heard the term land and ors. So this is a land graph when we have just one interval in between. These are ors when we have two intervals on the outside. So let's finish this question. We have our number line, but we want the intervals in both notations where f of x is greater than 0. So this is going to be an interval notation, -8 to -2. I'm using parentheses here because we don't have closed circles, and we have open circles because there's no equal to line here, so that's why they're parentheses. And then we could also say -8 is less than x is less than -2. Again, no or equal to lines because we're not given one above. All right, next problem here is our new graph. We want to know the values of x for f of x is greater than 0. So what does that mean we want? That means we want to know where is it positive. Well, what's different about this graph? This graph never crosses the x-axis. That means it doesn't have any real zeros. It just is all above. Well, what does it mean positive? Positive means above the axis. So we want to know over what intervals or for what x values is this graph above the axis. It's above the axis for the whole thing. So if we draw it as a number line, usually on our number line we put the zeros, but we don't have any, so I'm just going to put a couple numbers. Well, what values of x, what values on this number line are greater than 0? That's going to be all of the numbers forever and ever. Everything going to the left forever, everything to the right forever is going to be above this axis, which means it will be positive. So how do we write that as intervals? That would be negative infinity to infinity, or negative infinity is less than x is less than infinity. Then the next question, values for x for f of x is less than or equal to 0. Well, that means where is it negative? And negative means below the axis. So looking at this graph, are there any x values where this quadratic is below the axis? The answer to that is no. So if we draw a number line, we would actually have no dots, no lines, nothing to put on this number line. And therefore we have no intervals. There are none. There are no values for x that make this true, that make f of x less than or equal to 0. Here's the last question I want to look at with you. So this one we're actually not given a graph. That means we're going to create our own little sketch of a graph. So I'll go ahead and just draw axes over here. Well, what do we need to know? What did we need to know on the front of our page, like looking at this one? What were the two numbers that we used? -8 and -2. Where did we find those? Those were the zeros. So that means we want to know what our zeros of our function are in order to be able to graph it. Well, how can we find the zeros of this? We can factor it. So let's remember factoring. Some of you like to use the x method. Remember, with the x method, we multiply to get the top, which is 8. We add to get the middle, which is -6. If you do not know the x method, that's okay. Just use guess and check. So to get x squared, we know we need x and x. Well, what are our factors of 8? We have 1 and 8. We have 2 and 4. Which pair of those could I potentially add to get -6? Well, 1 and 8 are not going to work, so I'm going to use 2 and 4. In order to get a -6, I want them both to be negative. So I'm going to have -2 and -4. -2 times -4 is +8, and when you add them, you get -6. So here are my factors. When we're finding zeros, we want to set our function equal to 0. And now we can use our zero product property. So that's when we say x minus 2 equals 0, x minus 4 equals 0. Then to get the x's by themselves, we add 2 here to get x equals 2. We add 4 here to get x equals 4. So that's how we find the zeros of this function. You could also use the quadratic formula if you wanted to. So 2 and 4, let's plot those zeros on our little graph. So we know we have x values of 2 and 4. Those are our x-intercepts. The only other thing we really need to know for a rough sketch is, does it open up or does it open down? Well, for that, we look at this beginning term. Because that's positive, it means it opens up. So we know this opens up. We don't really care where the vertex is. All we care about is the zeros, and that really should have gone through that point there. Sorry about that. So our quadratic is going to look kind of like this. What's important is that we see where the zeros are. So let's answer these questions. First one, we want to know the values of x when f of x is less than 0. That means, where is it below the axis? So less than 0 is going to be from here to here. Oops. So we want this section. Where is it below? So that's going to be from -2 to -4. Notice that I use parentheses here because there's no or equal to. If it helps you, you can draw a number line, but I'm just going to write the notations. Then this would also be -2 is less than x is less than -4. Last one, what are the values of x when f of x is greater than or equal to 0? That's going to be this section and this section. So that means we're going to have two separate ones. We're going to have -infinity to 2 with a bracket, and then 4 to infinity with a bracket on that 4, because we are starting from -infinity to here, and then from here to infinity. And then, of course, we could write this as x is less than or equal to 2, or x is greater than or equal to 4.